Algebra. Catfish says hi. Solving systems of linear equations. This time we're going to use elimination. So let's go. So quick recap on solving by substitution. If you recall, this is actually an easier setup than we had. We usually had stuff like 3x plus y equals 0, and then we had y equals x minus 2. And we were replacing what y equals for that other y in the other equation, right? So in this case, they kind of did that a little bit differently, right? But if you look right here, they said y equals x minus 2, so they replaced this y for 3x. They replaced 3x for that y, and then they just solved for x. And that's what we were doing, and then we just take this x value and we plug it back into one of our first equations. So if I have y equals 3x, that means y equals 3 times -1, and I get y equals -3. So my solution is -1, 3. Oop, no, that's not right. Sorry. -1, -3. And it walks you through both the equations are solved for y, but we started with usually 1 in slope-intercept form, right? Solve for y, and then we had like a standard form here, which we kind of touched on a little bit. And then we just plug and go, plug and chug. So let's move forward to elimination. Elimination. Well, here's our example, but what does that mean? So if I'm going to add two numbers together, let's just take two numbers, right? Let's take 12, and I'm going to add 30. Right? Well, I add, this is our like addition algorithm. I just go top down. I add the ones places together. So 2 plus 0, that's 2. And then I add the tens places together. 1 plus 3 is 4. I add the ones together because they're like terms. They're both ones. And I add the tens together. Those are like terms. They're both tens. The same kind of principle applies here where we have two equations, equation 1, equation 2. What I'm going to do is I'm actually just going to add them together. But instead of ones places and tens places, I have the x places, the y places, and the constant places. These are like terms here. Let's highlight them. These are my like terms for x. These are my like terms for their y. And these are my like terms. They're constants. And just like our regular addition algorithm, we're just going to add from the top down. So let's start on the left. What's negative 4x plus 4x? Well, that's going to be 0 x's. So we even need to write that. What's negative 2y plus 8? That's 6y. What's negative 12 plus negative 24? Well, that's going to be a more negative number of 36. We'll now have a very simple linear equation. Actually, it's just a simple one variable equation. 6 times y equals negative 36. Divide both sides by 6. Can't talk right now. And y equals -6. From here, we are going to do the same thing we did before. We're going to take this value and we're going to plug it back in. I personally like to choose the one where I have the smaller numbers, and -2 is smaller than 8. So I'm going to plug it back into there. I get negative 4x, we're using equation 1, minus 2 times -6, because y used to be right here, equals -12. And then I just solve for x. So our steps are the same that we would normally do. I'm going to rewrite what doesn't get touched. Here I have -2 times -6. That's changing to positive 12. I have -12. I'll subtract 12 from both sides, and I get -4x equals -24. Divide by -4, I'm running out of room, my apologies, and I get x equals +6. So my solution to this system of equations is 6, -6, right? This is my x value, and this is my y value. Let's do another example. This one is also very straightforward. Equation 1, equation 2. When I add them together, I failed to mention this before, I'm going to look for the variable that has the same coefficient, but opposite sign. Let me say that again. Same coefficient, 6 and 6, but one is an opposite. So -6 is the opposite of +6. And so I am going to just add them together because these get eliminated. All right, so 5y plus 4y is 9y. 1 plus a -10 is -9. Divide both sides by 9, and I get y equals -1. Let's put that back into equation number 2. I'm going to get 6 times x plus 4 times -1 equals -10. It's going to be 6 times x minus 4 equals why did I do that? -10. I'm going to add 4 to both sides, and I get 6x equals -6. Divide both sides by 6. I get x equals -1. So my solution is -1, -1. Okay? So before, it was set up real easy. We had a negative 6x and then a 6x in the other equation. We just add them together and they went away. This is not so straightforward. So if one of the equations doesn't look the way we need, we can just change it. Here, remember, I'm looking for the same coefficient. There's a 1 in front of this y and a 1 in front of that y, but they're both the same sign. Please forgive the blurriness. So I can change the signs by multiplying it, one of them, by -1. So let's rewrite these equations, okay? I'm going to have, why wasn't that erasing? Let's erase that, please. Oh, darn it. Okay, whatever. I'm going to have 8x plus y equals -16. And I'm going to have -3 times -1 is positive 3x minus y, right? I'm changing the sign of every term in the equation. So I have equation 1 and then 2a, right? This is our next equation. I'm going to add them together. 8 plus 3 is 11x. 1 plus -1 is 0. -16 plus 5 is -11. Right? So we wanted the same coefficient with opposite signs. We didn't have it, so we just made one of the equations work. So we could change the sign. So I just take this and I plug it back into any equation I want. Let's plug it back into equation number 1. So I rewrite 1, I get 8 times -1 plus y equals -16. That's -8 plus y equals -16. Let's add 8 to both sides. I get y equals -8. So the solution to this system is -1, -8. Right? This was our x solution. This was our y solution. That's where these two lines intersect. Last but not least. So I have two equations. I don't have, my x coefficients are not the same. My y coefficients are not the same. Oh my gosh, what do we do? Well, just like we did in the last one, we can change one of them. And I'm going to change the one that just seems easier. What do I have to do to make the x coefficients match up? This is kind of like finding the least common denominator or least common multiple, right? When we work with fractions. So 10 is a multiple of 5. So why don't I just multiply 5 by whatever number I need to get to 10? But remember, if I have to multiply 5 by 2, I have to multiply everything by 2. So let's rewrite our equations. We'll call this equation 1a. It becomes 10x plus 2y equals 9. And then I get 10x minus 7y equals -18. Oh, you know what? I forgot something. They're the same coefficient now, which is good, but neither of them is opposite. So what we should have done is multiplied by -2. Let's write it in red, -2, which turns this into negative, this into negative, and this into negative. Changes the sign of everything. So let's add them together. -10 plus 10 is 0. -2y plus -7y is -9y. -9 plus -18 is -27. Divide both sides by -9. I get y equals 3. I take this. Let's plug it back into here. So I get 10 times x minus 7 times 3 equals -18, right? This was my y. I just changed it, right, because I know what it is now. Remember, variables are used for numbers that we don't know what they are yet. So here I'm just doing the multiplication. I get 10x equals 3. Divide both sides by 10, and I get x equals 3 over 10. So my solution is 3 over 10 and 3 for my x-coordinate and my y-coordinate. Is that right? Did I do something wrong here? I don't know that I did. I think everything is fine. -9. Oh, I see the problem. Do you guys catch the mistake? I am going to leave it, but I did make a mistake. This is not the answer we're looking for. So, if you can catch the mistake, let me know. I see what the mistake is. Oopsie daisy. It's late. I'm trying to make this in a hurry. So recap. First thing, yes, sometimes I make mistakes. That's okay. As long as we learn from our mistakes, they're not failures, just opportunity for lessons. So we want to find same number, coefficient of a variable with, and this is important, with the opposite sign. Okay? And then we add them together. I'll just write then add. Add the entire equations together. You're adding, just like we do in regular addition, you add the tens place and the ones places, you know, those get added on their own. Sometimes you carry. We're not carrying anything here. We're just adding and combining like terms. We're doing it vertically, okay? If not the same opposites, which seems counterintuitive, just that whole phrasing. Make it that way, okay? My suggestion is find the ones that you have to multiply by the smallest number. I could have chosen 7 in the last example, but then I'm multiplying, 5 times 7 and 9 times 7. I already made a mistake multiplying times 2. Imagine what my mistake would be if I did that. All right. Your assignment is going to be the worksheet for elimination, okay? And listen for the word. I'm not going to write it down. Same, opposite. 2 words this time. Same, opposite. All right. Everything you need. If you have any questions, you know how to get a hold of me. Take care.